Hi, this is about factor analysis. Factor analysis is 요인 분석 in Korean. So when we are using the factor analysis, firstly, it is used to extract the underlying factors or dimensions, and therefore this is a technique for data exploration. And also, the factor analysis is used in order to reduce the number of dependent variables. And factor analysis will result you a couple of sets of dependent variables after it clusters the dependent variables. Let's consider this example. This is a collection of various design masterpieces. Some look provocative, some look conservative. Here, the task is to develop a set of criteria to assess the characteristics of a product design. So here, we need a general set of criteria that can be applicable to judge the characteristics of various product design. You can brainstorm or look up some related literature to collect terms which might be useful to describe the characteristics. Then, perhaps among these pool of terms, some are actually describing very similar aspects. In my personal opinion, the usability and utility and functionality are maybe asking the very similar aspect of a product design. Therefore, perhaps we don't need to ask 3 times. Instead, we can cluster these 3 terms and label them as, for instance, practical aspect. This is my assumption. Last year, students of a research methodology class participated in a survey. I presented these 24 product designs, and I provided my students with a pool of 20 adjectives. I could ask them to assess the entire 24 products using the 20 adjectives, so 24 product design by 20 assessments, so a lot of questions. But it was on their free will, so I decided to ask them to randomly select any 5 products among 24 and then assess only those selected 5 using the 20 adjectives. Let me show you the data I collected last year. In this table, you are watching the 20 adjectives I have used for that survey. So each student made a couple of selections, so not 5. Some students made only 1 choice. And regarding their selection, they made assessments in terms of freshness or flamboyant, sensuous, weak, delicate, etc. until sophisticated aspect. So in total, I had 70 judgment. Now we can start a factor analysis. The analysis consists of 3 steps. First is to select a proper method. This is about how to extract the factor. We usually select the principal component as the method. This is called as 주 성분 분석 in Korean. Regarding the rotation, I will continue in next slide. The second step is to check whether your data are adequate for the selected analysis. We need to concern the strength of the intercorrelations among the items, so among the variables. It is recommended to inspect the correlation matrix for evidence of coefficients When you find many of them greater than 0.3 or smaller than minus 0.3, it is pretty much possible that the data are adequate for the factor analysis. But we would not inspect the adequacy manually. At least, I am not confident with myself. Instead, using SPSS, we can statistically check up two things. So check up the adequacy in terms of the following two things. The first one is Bartlett's test for sphericity, and the other one is KMO test. KMO stands for Kaiser-Meyer-Olkin. You don't need to memorize the all names. The Bartlett test of sphericity should be significant for the factor analysis to be considered appropriate. The KMO index ranges from 0 to 1, with 0.6 suggested as the minimum value for a good factor analysis. After then, you can actually use the result of the factor analysis. So when your data are not adequate, then you should stop here. As the last step, there are a couple of related issues to extraction of factors. We will cover them one after the other. We are again in SPSS, and let me show you how to perform the factor analysis using the data. Analysis and the reduction, the dimension, and then factor analysis. So select all dependent variables, so 20 adjectives, and I moved them into variable section, and then I check here to test the Bartlett's test for sphericity and the KMO test, and then as an extraction method, principal component method, in Korean 주성분, and I would check scree plot. And for the rotation, usually in design research, we like Varimax rotation. Regarding the rotation, let me add some more explanation. This is all related to the first step, selecting the method. Initially, you have extracted the factors, and this is before the rotation. So the variability of a variable n has the value of this with regard to factor 1 and the variability of this value with regard to factor 2. But if you rotate the axis, so rotate the factor 1 and factor 2 with this degree, this amount of degree, then suddenly the x1 has different coordinates in terms of rotated factor 1 and rotated factor 2. Although the variability of variable 1 with regard to rotated factor 1 is much reduced, but the variability of variable 1 with regard to rotated factor 2 is largely increased. And same thing happened to variable 2 and variable 3. In case of variable 3, the variability with regard to rotated factor 1 is a lot increased. Initially, the value was only this, but it has more contrast with the factor 2, and it has much larger variability here. The variability means the amount of information that the factor can explain the variable. And this example is showing you rotating the factors, keeping the angle degree of 90 degrees. So the axes are crossing or intersecting the other perpendicularly. But it's not always necessary in vector analysis. So there are two categories of rotation techniques. The first one is orthogonal rotation, and the other one is oblique. And in order to say the factors are independent from each other, or the dimensions are independent from each other, or you want to draw a two-dimensional coordination or a three-dimensional space, then actually you suppose that the dimensions are independent or perpendicular to each other, right? So in that case, if you are aiming at displaying your variables into such two-dimensional space or three-dimensional space, then you should take orthogonal rotation technique. And in orthogonal rotation technique, the factors are supposed to be uncorrelated. So they are supposed to be independent from each other. And the underlying construct are independent. Actually, they are saying the same thing. And the typical method offered by or available in SPSS are Varimax and the other two. And the Varimax rotation is the most frequently used technique. On the contrary, the oblique rotation allows for the factors to be correlated. So unless you intend to draw factor 1 and factor 2 in such a perpendicular way, and you conceptually just extract the dimensions, and if the dimensions are not necessarily to be perfectly independent from each other, so they are somehow correlated, and if you allow that kind of situation, then it's kind of a more mild way of extracting factors. So you can choose oblique rotation in case you allow the factors to be correlated. The most frequently used oblique technique is Promax. And then, okay. So, here is the output. We got larger than 0.6 for the KMO test. And for the Bartlett's test for sphericity, we have a significant result. I brought this table from the SPSS result. And in SPSS, the KMO index and the Bartlett's test for sphericity are offered. And the criteria is 0.6 and statistical significance. When you pass these two criteria, then you can accept that your data are good for suitable for vector analysis. And basically, without checking these two, you can do it. You can check the adequacy manually as well. You can check the strength of the relationship among the variables. In output of the vector analysis, you can check the correlation coefficients matrix. In that matrix, the variables, actually the dependent variables, are arrayed horizontally and vertically, and their correlation coefficients are calculated here, and same number here. And because they are symmetrical, we only need to observe only the half, right? So from the observation, if there are only few correlations above 3 in their absolute value, then you can assume that the vector analysis may be not appropriate for your data. And if you have larger assessments, then it's more possible that you will have more adequate, or you will pass the adequacy test. Now, how big should be the assessment, or should be the sample size? Practically, 10 cases for each item, but more loosely, 5 cases for each item. For instance, in our survey, I use 20 adjectives, so ideally, I should have had at least 100 evaluations. In our case, not every student participated as I have requested, so I had only 70 evaluations, so the sample size was only 70, but nevertheless, with that data, I could reach the adequacy test. Here is the correlations matrix. Here sometimes the coefficients are larger than 0.3, sometimes not. So without having this test, it's not easy to conclude whether there are enough number of big coefficients or not enough number of coefficients. So therefore, it is helping you to overview or get a rough idea whether your data would be adequate or not. But actually, I think I recommend you to check up this table instead. Because we have checked that the data were adequate for factor analysis, we could continue to the factor analysis. And this is the last step, extracting factors. And in this step, we need to know several terms. First one is a factor loading. It indicates the correlation coefficients between a variable and a factor. And when we square this value, then that squared value corresponds to the ratio of variance that is explained by the factor. When we add the factor loading scores, then we can calculate the eigenvalue. When eigenvalue is bigger than 1, and in script you can observe it more easily. Then, based on that criteria, you can determine how many factors you can extract or you better extract. And the smaller, actually, the better. So, with these very unfamiliar words, I will bring you to SPSS result, where to find these very unfamiliar terms and what they actually mean. Okay, in SPSS, you will see this matrix. In English, is called component matrix. And here, the 20 adjectives are listed. And 6 factors are extracted because if you see the script plot, then the eigenvalue is exceeding 1 with 6 factors. If you add one more factor, then the eigenvalue is smaller than 1. So up to factor number 6, the eigenvalue is still exceeding 1. So in SPSS, actually it gives you the whole number of factors as far as the eigenvalue is bigger than 1. In PowerPoint slide, the factor loading is indicating the correlation coefficient. So this is a factor loading values, and this is a correlation coefficient between a variable and a factor, and the factor 1. So this 0.575 is a correlation coefficient between fresh and factor 1. Going back to the PowerPoint page 8, the factor loading, the squared value of factor loading corresponds to the ratio of variance that is explained by the factor. So if you square this value, then it will be roughly how much? It will be roughly 33%. The 33% corresponds to the ratio of variance that is explained by factor 1. So factor 1 can explain the 33% of the variability of freshness. But if you rotate the factors, then the variability has more clear distinction. For instance, here the difference became more drastic, and it's here more clear. Factor 3 has the highest ability to explain the variability of a fresh. And in this table, it is still quite difficult to distinguish which variables are clustered to with which variables. So I think in analysis, you actually can reorder or sort the order of the variables, and sort like this. So script plot and yes, so the order is slightly different from previous one, but it is much well sorted. So let's see here. Neat, calm, clear has relatively much bigger correlation coefficient to factor 1. So they are clustered to factor 1, or the factor 1 has ability to explain the variability of these three variables. And then luxurious, elegant, and the opposite of cute is clustered as the factor 2, and then stand out the opposite of classic and fresh, and the opposite of sophisticated will be clustered as another group, so factor 3. And then here, lovely, cozy, charming, cheerful. Yes, it suddenly decrease. You see the sudden decrease, right? So up to here, these 4 belong to factor 4, and sensuous, delicate, flamboyant, the 3 belong to factor 5, and then light, weak, the opposite of comfortable, belong to factor 6. So there are 6 factors, and you can label each factor on your own creativity. And that's one of the before class quizzes. As we have exercised in SPSS, when you are ready with the factors, then you need to assign the label, so the name of each factor. And the rule is that you are assigning the common characteristics of items of factor. So in our research, we consider all of them as the flamboyant aspect of a color. And for this, we consider that as elegant aspect of colors. So you can find your own way to create a name for each factor. And in other aspect, these 4 variables are actually latent. In Korean, 잠재 변수. So they didn't exist before, but through factor analysis, we discovered that there is an underlying structure which consists of these 4 factors. Last year, who actually participated in that survey shared the results. And in a class, we tried to display the independent variables, so the design masterpieces, into 2-dimensional coordinates, the factor 1 and factor 2 here. 현재, 세진, and 동규. Let's zoom in the results. So on factor 1, some products were positioned in these two-dimensional coordinates. Among the 6 factors, we took only the first 2 factors in order to create the two-dimensional space. And in this two-dimensional space, each item, so each product, had a factor score, and that factor score is actually the coordinates. So factor score on factor 1 is the x value and comma. The factor score on factor 2 is the y values. Then you may be curious how to get the factor score. So let me show you how to calculate the factor score. So the way to calculate the factor score on each factor is like this. For example, we had assessments for this item. Therefore, we can have an average score of love pot on neat scale, calm scale, clear scale, and luxurious, and so on. So let's say the average score for neat was 3, and calm was 4, and clear was 3, and so on. Then the factor score of this love pot on factor 1 is the average rating on variable n. So average rating on variable neat multiplied by factor loading on factor 1. So 3 multiplied by 0.847 plus 4 multiplied by this plus 3 multiplied by this. So after clear, actually the factor loading on factor 1 of the other variables are relatively smaller, much smaller than this. Therefore, their influence will be much smaller than the impact decided by these first 3 variables. And this way, the factor score of this product on factor 2 is 3 multiplied by this, 4 multiplied by this, 3 multiplied by this, and the averaged assessment on luxurious multiplied by this and this. So in this way, we can find the factor score, 6 types of factor scores of this product.